All right. So, reminder, we have our math spirals out. Open to a clean page. Okay. First things first, date on the top right-hand corner. Today is 5-30-19. I do want you to set up your notes 2-column notes, but 1 column rather skinny to write the problem, and 1 column rather wide to do your work, to do the strategies and solutions. And believe it or not, this is problem string number 24. We didn't quite get through the rest of it, so we'll finish it up here. Okay, 2-column notes. One's rather skinny, one's rather wide. The skinny column is labeled problem. The wide column is labeled strategy/solution. Okay. Now remember, with the problem strings, it's all about what strategies you use. As Daniel J. always says, it's about the journey, not the destination. So talking about the different ways that we got the answer, what's the most efficient way, because here's the thing, all of our brains work differently. So what works best for you is what you should be using. But take the time to listen to your table and see what strategies work for other people, always. So once you have your 2-column notes set up, I'm going to go ahead and write the first problem. And it is 140 divided by 14. 140 divided by 14. And go ahead and start solving that bad boy. I see. If you've already solved one way, you have just a few seconds to try to solve another way as well. Get a couple strategies down if you have the time. I'm going to give you about 15 more seconds. All right, go ahead and finish up your last thought, last digits written down. Okay. If you found one way to solve it, excellent. If you found 2, great. If you weren't even able to get through 1, fantastic, because your group's going to help you out and share with you what they did. So our groups are a little wonky, but I still want you to put your heads together with your actual table group. So that would be Bear and Hunter, and then you 3 here on the end. And then, of course, you 4. Real quick, heads together about what strategies you used to attack this problem.
Yeah, I know
So connecting it to multiplication. Right.
What did you do?
Oh, dude. Hey, sweetie. Come on over here. You can sit right here. We're just talking about math problems.
I started with this one because I knew it would just be plopping on the 0.
Plopping on the 0. What's that? Okay, long division. Great way. Finishing up your conversations in 10. Good. Right. Fantastic. Okay, I can't wait to hear about what strategy you guys used. Who would like to start us off? Abby.
I did 10 times 10, and I knew that was 100, and then I added a 4, and then I did 10 times 14, and that was 100.
Beautiful. So she did 10 times 10 to get herself up to 100. And then you asked yourself, okay, how much further do I need to go to get to 140. So 100 plus what will get me to 140? And what was it, 40 more? So you figured that out, and then what was your next step?
I did 4 times 10.
Oh, and then you did the 4 times 10. Look at that. You distributed it into 2 parts. What is that called when we do that, David?
Distributive property.
Distributive property. Nicely done, Abby. She distributed out her 10 first because she saw it on her 10 facts. Got that done, and then just found the difference and used multiplication to find that. Distributive property. Always a winner. Especially with those factors that are out of our wheelhouse. Like we know our 0 through 12 pretty solid, but when you start working with 13, 14, 15 and beyond, it's a really good job to just break those apart because we don't have those memorized. Distributive property. Sweet. What else did we use? Micah?
Long division.
Standard algorithm, just straight up long division. How did that work out for you? Okay, so walk me through it. 140 inside the house, 14 on the outside. All right, so I'm going to cover up my place values. Just the hundreds place is showing. How many times can 14 go into 1?
0.
Okay, I'm going to uncover my next place value. How many times can 14 go into 14? 1. And 14 times 1 is?
14.
14 minus 14?
0.
Okay, what's my next step?
Bring down 0.
Bring down the 0. All right. How many times can 14 fit into 0?
0.
All right, with no remainder. 10. Cool. All right, any other strategies that you guys used? Jose?
What I did, if it's in the hundred, I'm going to strategy. So I do tens for the hundreds.
Mhm.
If that doesn't work, I go on to 11s and 12s until I get my answer.
So kind of like Abby, starting with the 10.
Yeah, but if I, like, 100, they're usually used for tens. When you have a double digit, you have double digit multiplication of 2 things.
Yeah.
So I use that. I put 10 at the bottom, that didn't work, 11, then go on until I get my answer by 10. And if it's in the thousand, I use the hundreds.
Oh, excellent strategy. So he's saying he noticed that the dividend was in the hundreds. So he was pretty sure that it was going to be a double digit by double digit number because the product was so big.
Yes.
Wow, that was really good critical thinking. Interesting. I love how our brains just work differently. Kinsey Fillmore, what do you got?
What I did is I know my tens facts pretty well.
Okay.
So I started out with 14 times 10 to see if I need to get any problem bigger or smaller.
Mhm.
And I got 140, so that's all I need to go do it, and I got my answer 10.
So tell me, how did you get to 140?
I did I know that I can take off the 0 and do 14 times 1, but I'd still have to add the 0 back on.
Gotcha. So you're covering the 0, doing the 14 times 1, and then I think I heard Bella say plopping the 0 back on. Right. Basically what you're doing is a place value strategy. You know that every time we add a 0, it's bumping it over a place value. So if you're doing 14 times 10, that's 140. Plop another 0 on there, it's 1,400. So you're just moving over a place value every time you add a 0. So I'll call that a place value strategy. All right, that's 3. Anything else? Hunter? Area model. So talk me through this. You drew a rectangle?
Yep.
Okay. And what went on the side of the width?
The
The divisor of 14?
Yep.
And then you put 140 in the middle of the box? And then you were solving for the excellent area model. That's a really good visual model too, because if we were to work forward or backward from 14, we could just add to the area model or take away from the area model. So that's an excellent one to put down on the paper right away. Yes, Micah?
I also saw that 14 was in the base number of 140. So I did 14 times 1 since that equals 14, and then I just closed the 0.
Perfect. Place value strategies. Anything else I'm missing? Did I cover it all? Megan's giving me a thumbs up. Alrighty. Are there any of these in particular that you just don't get? Jose.
When I was talking, I don't get what the 10 times 10 thing you guys have to do.
Oh, this first one?
Yeah, why did you have to split?
Oh, good. And Megan's shaking her head. She's like, yes. Okay, so let's do it. Let's use the AVID strategy. I don't get it. Right? When you don't get it, I can't help you, but if you tell me exactly what you don't get, that helps me. Okay, so let's start here. What do you understand about that problem?
How you have to do 10 times 10 to get 100.
Okay, anything else you know?
4 times 10 gets to 40, so that's why so that's kind of how you have to plus it.
Why would I have to plus it?
I don't know, but that's the confusion.
Beautiful. So we pinpointed it to why do I have to add those two together? Beautiful. So I can answer that question. So when we're dividing by 14, that's a double-digit number. And it's a hard number to work with. It's not one that we have memorized. So instead of working with a difficult number like 14, Abby broke it up into a 10 and a 4. Okay? I'm going to write that down on my paper just to get that on there. 10 and a 4. You remember number bonds, how we break things apart. So she broke it apart into 2 simpler problems. She solved one simple problem, the other simple problem, and then put them together for the answer.
Okay, that makes sense.
Beautiful. Love it. Anything else we don't get? Megan.
Why the 140 in box, not 14?
Oh, on the area model.
Yeah.
Okay, so let's talk about what you do know. I have an area model. There's a square. 14's on the outside. 140's on the inside. So what do you understand about this so far?
I know 14's in 140.
So you know 140's in the box.
Yeah.
What else do you know?
I know that we had a 0.
Okay, you see the 0 on there connecting it to the 14. Anything else that makes sense? Okay, so she recognized the 0 added to 140 looks very similar to the 14, so she knows there's a relation there. And she knows that 140 goes in the box, but why does 14 go outside of the box? Now, if you remember back to the like when you guys used to do arrays in 3rd grade, was like rows times columns?
Yeah.
Or what did we say?
Rows times.
Yeah, rows times columns. If I were to actually draw this out, 14 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I go again, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28.
That'll take forever.
Right. To get to 140 would take a long time. I would keep on going till I got to 140, and then you guys would tell me, stop, and then I'd count my number of columns. I would have 10. So instead of drawing 140 dots, I'm just writing the number 140. And like you always do, you use your multiplication facts, right? You do 14 times blank equals 140, and I saw that you plugged in 10, no problem. So instead of drawing 10 columns of 14, I just wrote the number 140. Saves my pencil, saves my wrist. All right. And saves the paper. Yes, Emily.
I got a strategy like 140 times 14, but it didn't really work out.
140 times 14?
Yeah.
Oh, okay. Because our original equation was division. And you know that division and multiplication are so closely related, right? Because basically multiplication is the opposite of division and vice versa. So we got a little confused on that one. Do you understand now why we divide? Perfect. Why do we divide rather than just multiply? How does that change the answer?
Because multiply gets the answer bigger, and division gets the answer smaller.
Exactly. So we would be way off base if we multiplied. Good thing you caught that. Okay.
There's one big problem that does make it smaller.
What's that?
100, like to say, as an example, 128 divided by 1.
So dividing by 1. Right. Keeps it the same. Okay. I'm going to give you one other equation. We've got about 7 minutes. As you're doing this equation, I want you to think about how it's related to the one we just did. Okay? This one is 126 divided by 14. 126 divided by 14. Okay. Good. Nice. All right, I'm going to interrupt you just real quick because I want to talk about a few things before we dive too deep into this. We had two equations. We had 140 divided by 14, 126 divided by 14. Straight away, I'm noticing a couple things. I have the same divisor. I'm dividing by 14 in both of these problems. Okay? What else do you notice? Christensen.
That like our bigger number is that it is in the 100s.
Okay, our dividend is in the 100s. So it might still be a double-digit factor that we're going to figure out to multiply by. Anything else? Jose?
It can't be 10 or above because it's 26.
It can't be 10 or higher because we just solved for 140 and that was 10. So I know that my answer is going to be less than 10 this time.
Yes.
All right? Because when I did 14 times 10, I got a product of 140. Well, in this case, it's not going to be that high. So I know it's going to be less than 10. Micah?
I noticed that when I did 140 minus 126, I got 14. So I noticed it was a group
Ooh.
away from
A group of
14.
A group of 14 away. Ooh, okay. Continue. I want to see these strategies here in a minute. All right, go ahead and talk to your groups. Talk yourselves through it. Where are we at in the process? Okay.
I did 14 times 9 and I got me to 126.
So knowing that it was going to be less than 10, did you just start with the very next number less than 10 and tried it out? Okay.
I did those strategies and then I did
Oh, perfect. I'd like you to share that out when I call out. Okay? That's a good one.
So that was one group subtracted from. So we'd have to.
Oh, cool. Okay. So you did 140, subtracted 126 to find out what the difference was. And like Micah was saying, it was one group of 14.
Did you subtract 126 and 14 then?
Nope. You found out that the difference between those two numbers
It's 14.
is 14.
So that's one group away, so you take away 1 from 10.
So if you think the first equation was 10 groups of 14, now you're taking away a group of 14. What's one group less than 10?
That's the area.
9 groups of 14, right? So I would maybe even just do the multiplication, see if that checks out.
I did that too.
Since division and multiplication are so closely related, it's always a good way to check your work. Back to your math. Right. Sweet. So excited to hear about this. This one's a little, you gotta dig a little deeper. Gotta dig a little deeper on this one. All right, solutions and strategies that we used to solve this one. Bear, start me off.
I used the over strategy.
Okay.
What I did was I did 14 times 10, giving a 140. And I took group away. I took group of 14 away to see what that would do to me. And then that got me to 126.
Okay, so you started with what you knew, 14 times 10 was 140, and just started taking chunks of 14 or groups of 14 away to find out how many steps back you needed to take. So 140 minus 14, 0 minus 4, can't do 3. Good morning. We are not. Isaiah and Cayman are not with us yet.
Ooh, I like the new arrangement.
Thank y'all.
Well, I'm taking your chart because guess what?
It's time.
Tomorrow's the assembly, although I don't know, I haven't really counted, but
Mrs. Clarendon was looking pretty solid.
Mrs. Clarendon had more than you, so.
Oh,
We'll see.
All right, thank you. All right. So, Bear, I did 140 minus 14, which was one group of 14, and I got 126.
Yep.
So what does that tell me?
That the answer is 9. So I take one group away.
So instead of
Minus 1.
10 groups of 14, actually 9 groups of 14 will get me to 126. Christensen, anything you want to add to that? Because I know you solved it similarly.
I also did an area model.
And how did you go about that?
So first I did the over strategy to get my answer to fill in the blank. So then I got 14 times 9 equal 126.
So did you draw an area model like we did in the first problem? And then took a group of 14 out? I love it. So he had the area model. He had 140 in there, 14 as his divisor, and he said, hey, wait, I'm going to take away a group of 14. And instead of now having a length of 10, he has a length of 9 because he took one column out, and now he has 9 groups of 14. So same strategy done in 2 completely different ways. Barry used like standard algorithm multiplication to figure that out. You used a visual representation of the area model. Perfect. David, what do you got?
I used the 9 tricks.
The what?
The 9 tricks.
Tell me more.
I did 10 times 9 equals 90. And then I knew it ends in 6. And that ended in a 0, so it had to have 6 at the end. And so I think that 36 is an answer. And then I put it like this, 36.
Yeah.
And then I added them together. And I got 126.
Holy mackerel. Okay. How did you know to start with 9s?
Because, like, 4 times 9 equals 36. And
Okay.
so you can end
Oh.
in a 0 with 9s, every number you can.
Okay.
And I knew 36 would be, like, 110 too much, because it's 26.
Mm-hmm.
So
instead of adding 100. Oh my goodness. Did you guys hear that? That was some out of the box thinking. So he said, I knew the answer was 126. It ended in a 6. So he thought, okay, what products do I know that will end in a 6? Could have been 4 times 4 is 16. 9 times 4 is 36.
16 times 1.
There really isn't any other ones besides that.
6 times 6.
6 times 6 is 36. Ooh, that would have been a good place to start too. So he decided to go with nines because he knew it needed to be a higher factor because it's 126 is a pretty big product. So you did 9 times 4 to get 36, and then basically said 36 plus what number is going to get me to 126. Yikes, stripes.
Or you could do 11 and 4s.
Yeah. Well, that would have got us too much, right? 11s and 4s. Yeah. Jose.
Well, what I'm going to say, you're going to need to write on there to understand it better.
Okay, tell me.
Draw a circle right here, and then
Right here.
make 3 lines.
3
Draw
lines.
a 9 right there.
A 9 in the middle.
Yes.
Okay. And 3 prongs coming off of it.
Yes.
Okay.
So 6, 7, 8.
6, 7, 8.
These are all factors to get to the answer, because what I know is you take 214 away, that basically gets you the answer, and it gets you way closer and better. So these 3 numbers are the closest to that answer.
Okay.
So you're gonna pick which one of these is the right answer.
All right. So you're laying out your options, and then process of elimination, finding the one that works.
Yes. So since we have to do 14,
Yes.
I minus 14 away each time till I get to the answer. And then I look at these and see which one got me to that answer in the right way.
Did you use multiplication to check?
Yes. And I use a couple other things just in case.
So like what, like repeated addition, or what else did you use?
I use the area model,
The area model.
and I sadly use that because I don't like doing that.
Oh, not your preferred method, but you tried it.
Yes.
Excellent. Thank you for trying new things. So like we talked about, we knew the answer was going to be less than 10. So he just wrote his options 9, 8, 7, 6. He knew it was going to be one of those numbers that are going to get him close to 126
Or get the answer.
or get the answer. So he just used process of elimination and used kind of a variety of strategies to find it. I'm going to write variety of strategies. What do you want to call yours, David? That's probably, what do you think?
Purple thinking. I'll be both thinking. I call that.
I would agree. I think that's distributive property.
You could call it the David strategy.
We could call it the David distributive property. Distributive David?
DDS.
Distributive.
D's.
Yeah. I mean, it was a little bit of his brain, too. He had to think about, okay, what is going to end in a 6? Pulled out that 9 and then did distributive property.
DDS.
Interesting. Yeah, because what you did, you pulled out the 10 and the 4 right here for 14. And then found out that 9 worked. Yikes. Yes, Kinsey felt.
I had another strategy.
No way. Tell me.
I did 14 times 5. I know 126 doesn't end in a 5, but I wanted to see if I'd have to get a greater number or a less number.
Uh-huh.
That I got 70 for that. I knew that was way too less. And then I did 14 times 7 because I know my 7 facts pretty well.
Oh, good.
And I got 98. I knew I still needed more. I knew I couldn't just add a group of 15 because that'd still be too little, and that would be 8. So then I decided to do 14 times 9, and I got 126.
She even wrote herself a note. Can't go above 10. Good reminder. 14 times 5, 70. 14 times 7, 98. Oh, okay. Kind of like Josiah's method.
Yeah.
Working with numbers that you know it probably could be, and then pinpointing it exactly to the number it actually is. Emily.
I do long division.
Okay, let's do that. Standard algorithm. How did that work out for you?
I haven't done it yet because I ran out of time.
Okay, let's look. Because sometimes with long division, unless you know your facts, it kind of doesn't work out. So let's see if this works. So I have 126 inside my house, 14 plopped right outside, covering my place values except for 100. How many times can 14 fit into 1?
0.
How many times can 14 fit into 12?
0.
How many times can 14 fit into 126?
9.
Well, we know that now, but did we know that before we started?
No.
No.
You have to check it with multiplication.
Yeah. But it would work. Let's try it. 14 times 9 is 126. Minus 126 is 0. Nothing to bring downtown. We got it. The answer to that one is 9. Alrighty. Is there anything in particular that you don't get? Kinsey.
I didn't really understand Josiah's strategy when he had the 9 with the 6, 7, and 8 coming out of it. I didn't know why there was a 6, 7, and 8 coming
Okay.
out of it.
So what do you understand about that so far?
That 14 times 9 equals 196.
Okay.
Because, yeah, I know that.
Right.
He used different numbers to try to pinpoint it.
Okay. So you use this
And that's where the 6, 7, and 8 come from.
6, 7, and 8 come from. Oh, okay.
And that's pretty much it.
Okay. So it was very similar to your strategy. He knew it was going to be less than 10. So he just picked the 4 numbers closest to 10. 9, 8, 7, 6. And I think I walked around and saw a lot of people doing this in very different ways. Because Daniel Jackson did the same thing. He was like, I know it's going to be less than 10. I'm going to start with 9 and work my way back until I find the answer. So this was just a visual model he used to, to eliminate the ones that didn't work. All right, anything else? Yes, Jose.
Why is this problem important?
Why is this problem important?
The whole thing.
Because what if I have $126 to share amongst 14 people? And you're one of the 14 people, and I give you $5. Is that fair? No, you deserve $9. So if I'm paying someone, I want to make sure I'm paying them exactly what they need.
Yeah, but what I'm confused about, like, why do we need this problem? Aren't we gonna learn it another time? And why are we learning it now?
So then a year we're ready for 5th grade.
Yeah, seriously, because in 5th grade it just gets harder. Then they're going to start giving you problems like 126 and 75th
Yeah,
hundredths.
my brother did get coached a lot. Fifth
Yeah.
grade has been hard.
This is the foundation of what you'll need next year. All right.
How are we going to do that?
Sweet. Oh, it's going to be a blast. You guys are going to do great. Okay, let's close this out and go ahead. Let me have this group go ahead and put your math spirals away first.